Hi, this is a presentation about a new technology, the Human Digital Twin, to enable intelligent environments, specifically how humans and agents interact in such intelligent environments. In order to enable intelligence, we need to have a concept. What do we mean by intelligence? We mean by intelligence the ability to have intentions and prediction. So intention is to develop goals. Prediction is monitoring how these goals are being implemented. For example, if we have a target performance and we monitor that target, at some point of time, this is the actual performance, and at some point of time there's a change in the environment, in the systems, and then there's a deviation. It takes us some time to realize there is a deviation. It takes some time to make assumptions about the reasons behind it. It takes some time to implement the countermeasures, and once the countermeasures are implemented, it takes some time for the system to respond, and at some point of time we capture the deviation. The intelligent part is, or the intelligent version, the proactive one, is to keep predicting our environment, keep trying to understand what might happen if we do certain actions, and this way, if we predict changes earlier, so we use that time to develop the action plan. Once the prediction happens, we implement these plans, and then we can capture that deviation much faster. And that is why prediction is key in effective intelligent environments. The ability to predict an intelligent environment is a kind of a currency. The higher the level of predictability, and is the higher the value of the people who do the prediction or the environment itself. So what is prediction? Again, in more specific ways. So the prediction is about the capacity of an agent to assign probabilities to interaction, so to its interaction. Again, we are talking about a human digital twin that is specific to people. That is why prediction here is with respect to a person or an agent. So prediction is if that agent or person takes action A with the other system or other agent. Prediction means it can capture the possible outcomes and assign some probabilities to them. It sounds simple, but this is exactly what prediction is about. You remember the movie Terminator in 1991? What we are talking about, the human digital twin, is something close to that idea, that as that Terminator was walking around with certain objectives in mind, it had some kind of survey or scanning of the environment about what might fit that objective. That's exactly what we mean by the human digital twin. When a person interacts with their environment, they will have another layer of scanning that calculates some probabilities about what might happen, and at some point of time provide also some instructions and recommendations. And this is the essence of the human digital twin. How to enable then complex intelligent environments? How to enable all of those people to act according to that way? So we need to improve their ability to predict what they are doing, and this means that if we have an environment with so many active agents who has intentions and who make decisions, each one of them then will be equipped with their own human digital twin that will help them predict what happens when they interact with their environments, and then provide also recommendation for them what to do when. Look in such a future environment, Industry 4.0 or smart factory. So if we have this environment and we have that person, so we will try to help that person who is involved in clear tasks. I mean, these person, when they perform their jobs in this environment, also the agents or the systems, they always have a set of rules and set of tasks that they need to follow. So that person here will be provided with their own human digital twin that will help them manage these interaction with those partners for that specific objective. So in that environment, that person will get their human digital twin, and the human digital twin will create a map, a representation of how the person interacts with another partner and the probabilities of the responses. This would look like this. It is a kind of a standard representation where these are the different partners with which this person interacts, and these are the different probabilities that these values that collected over some specific period of time. And this is the essence of the human digital twin. It is able to capture interaction probabilities across multiple interactions in that environment. Once we have that representation, we can then understand interactions patterns or can learn them. How does the digital twin do that? Digital twin has three major components: representation, learning, and monitoring. The representation is just what we just talked about. So if this is the person, these are the communication channels with their environments, and in these modern environments, even today, all of these interactions leave a digital trace. So the human digital twin would have a communication clients. These are very small application that will be installed at the different communication channels and just read the messages in exchange between that person and the environment without any consideration for the content of these messages. So the digital twin does not see what is in the message, rather it only sees that there is a message between this person and that system, and that those were the responses. And once we have that representation, then there is a component with using machine learning to identify the patterns in a very classical machine learning way. And once we agree that those patterns are the ones we desire, then they will be monitored by this component. What is the application of that? What are the use cases? So if we imagine a person in a human being living in a smart environment, or a planner or an analyst or an operator in an environment where they interact with a lot of systems, a lot of other partners, so the human digital twin will be supporting one of those persons and then create this kind of representation, out of which we learn the interaction patterns, and then they can automate some of the stable patterns. They can improve and identify deviations, which would improve that interaction, will lower the cognitive load of the person by identifying or alerting them early about the deviations. And in the more advanced stage of the human digital twin, it can use that interaction, that representation, and the patterns to develop action plans or policies. Where are we right now with the development? We started developing an Android app. It is called the Twin App. And what it does is something very simple, and this is just the representation we saw. These are the applications a person uses on their phone, and this is the 24-hour timelines, and these are how often these apps have been used at what time. And this kind of information is available on Android and iOS. They provide this kind of information, however, in a little bit different view. The difference is that these are daily views. So the next step for us is we plan to take these daily views and then identify over longer time. And this is where we will start see usage patterns specific for that person. The vision is that once we stabilize this part with the phone, then we can keep extending that to the car, to the smart homes, to system at work, and so on. So it is also not only about the standard representation, but how to grow those patterns step by step. That is also a key to the approach. So it is not capturing the entire environment once, rather it is choosing first which are the closest pattern to a person, and then keep extending them over their different activities, daily different activities. Another prominent example for or use case is the aviation, where there's a lot of research about enabling human-machine teaming. So again, we have a pilot, we have a lot of systems in here, we have the tower, we have ground crews that also support them. And the advantage of aviation environments, they are all digital. There is a record for every single interaction that's happening. So when we have a digital twin, it will capture, again, the pilot's interaction specific to that person, to that pilot, with the system around them in a certain context, and then identify patterns like system checks up to takeoff and landing patterns, and so on. Once we have this kind of patterns, they can be validated and that they are the ones we want, and then monitored by human digital twin. They can also be used to train, to accelerate training. So an experienced pilot will develop that kind of patterns that can be used to monitor less experienced pilot, or it can be used to train agents how to perform the task of a pilot. The major point about aviation specifically, if we imagine that all of the people involved, I mean the ground crew, the maintenance people, the tower people, and so on, they have this kind of representations, and then we monitor deviations across all of them, then a single event that is unexpected can be used to alert all of them, and this should minimize the risk of this complex environment. The last use case is health. Most AI health solutions right now are disease specific. I mean, they take one or two systems of the humans, and then they collect the data around them, and then they detect diseases and so on. The idea of the human digital twin is more comprehensive, so that we can have a record of all of the systems of a patient. I mean, it's a patient human digital twin that capture all of their history and diagnostic in certain context, and then identify patterns, and these patterns would be specific to that person, and it will enable, this kind of view would enable AI to early detect deviations from normal situations, and early detect health risks. It needs to be said at this stage that, for example, for a person, for representing their health, these here would be maybe a couple of thousand columns at least, and then the timeline would also be very large. However, for AI, that's exactly what is needed, that we have a consistent large set of data that provide even more insights about how those people interact with their environment and all of their health risks, and identify them as early as possible. How to start? What is the typical approach? And this is also a purpose of this presentation. We hope that we involve with people who are interested to develop such use cases. So the idea is that we identify a process somewhere in an operational environment, identify the active players in there, identify their communication, install the communication clients, and then express all of this communication in the representation. And that is the key to the whole environment. The whole concept is how to consistently represent these interactions in a consistent way, and that is also the content or the scope of the patent that's being applied is only the representation part. These two parts are standard, machine learning and the monitoring part. So once we identified the process, the scope, installed the clients, captured and represented the communication, then we start learning patterns. Having patterns by itself is key, because then the process owner can decide, is this the pattern of interaction I need or not? Change the pattern, change the probabilities, and once the patterns are stable, then they can be provided to the monitoring, which can monitor the execution of the pattern or make recommendations about what to do when, a kind of a policy. So the last slide, if you remember the Industrial Revolution, it enabled very at that time, very complex instruments and machines and so on. And a key to that complexity was that they developed in parallel a consistent system for measurement. Otherwise, they could not make the same parts in the same countries, the spare parts and so on. So the Industrial Revolution was enabled largely by having a standard system of metrics. So this is what we are hoping from the human digital twin. It is not just a solution to enable or help people. We hope to develop also a standard way to represent how humans interact with their environment. And once we have that representation, we can then learn and increase the complexity of the environment. Thank you for your attention, and there is a download version of that presentation you can find here, and would be glad to answer any question. Thank you.